Hello and welcome everyone to the area chapter. This is more of a pull out. We're not really going to go over this in class, but this is just in case you forgot how to find some areas of some things. And this stuff is going to be very important when we do get into our actual volume chapter. That's why you see letters A, B, C, D, and just some examples here. Now, the reason for that is, like I said before, this isn't in your book, but this is stuff that you need to know beforehand and just a little refresher for you. All right, so what we're going to do is we're going to start easy and we get a little more difficult as we move on. So the first thing we go over is areas of triangles and parallelograms. All right, so at the end of today, you'll be able to identify the parts of a parallelogram, find the area of a square rectangle. That's pretty easy. Parallelogram and triangle, understand the area of the congruence postulate, understand the area addition postulate, and find the area of some irregular shaped figures, okay? We're going to end all these lessons pretty much with irregular shaped figures, which is more where you should be, as the other areas are more like, I would even say elementary school type things. All right, so let's continue on. Got a parallelogram here. We just went over what parallelograms are, so you guys should know what the bases and the heights are. So you need to establish what both pieces are before you find the area. So the parallel sides of the parallelogram are its bases. Remember, it has two sets, all right, and they are opposite of each other, all right, and they are congruent. A little rehash of, what was that, 6.3, right, 6.3? Height of a parallelogram. Now, the height of a parallelogram is the shortest distance between the pair of bases. Now, in order to find the shortest distance between two lines, what you do is you take the right angles between those two lines. All right, so it's perpendicular to both bases, so it forms a right angle here, right angle down there, and it forms, there you go, forms a right angle. So the height has to form right angles with the two bases that you are going between. Okay, if not, it's not the height, because it's going to be longer than the height. Now, label real quick what the height and bases are. Look at these. All right, let's look. First one, your base, okay? Dash line is your height. Blue is the base, red is the height. Got it? Awesome. Let's move on to the next problem. Bounce around today. Postulate area of a square postulate. Okay, postulate. Postulate theorems, pretty much the same thing. Some are provable, some aren't provable, okay? Pretty much both stand for rule. Back to chapter 1. All right, so area of a square postulate. The area of a square is the blank of the length of its blank. Ready? And the point you filled in is the square of the length of its, 5-letter word, sides. Maybe I should have said 4 with an S. So the area of a square is all the sides of a square we know are equal. So when you square the sides, it's just S squared. Or you can just do side times side. All right? Pretty easy. Area of a rectangle. Remember, a rectangle is not a square, but a square is a rectangle. Area of a rectangle is the blank of its blank and blank. So what do? It's the, let's turn this into words. Product stands for multiplication, of its blank and blank. Hopefully you said length and width. If you didn't, you can also say height and width, height and length, all that stuff too. Pretty much what you do is you multiply the two sides. So the area is length times width. Area of a parallelogram. So here's where one you may not have seen before. Area of a parallelogram. Now, as you can see, similar to the area of a rectangle, because if I take a parallelogram and I kind of push it over, you get your rectangle, right? Because a rectangle is a parallelogram. So what do you think the area of a parallelogram is? Look at the colors, it might help you out. It's the product of its, what do you think these two things are? Of a, what's that? Base, right? And the base is corresponding base. No, you would multiply the bases. You'd multiply the base by its height, all right? So the area just equals base times width, base times height. You can write it either way, okay? I just called this width instead of height. It doesn't really matter. Once again, words are interchangeable. That's pretty easy, isn't it? Area of a triangle. It is half, where we at? The product, okay, of a blank and blank. Base and its corresponding right? Area equals 1/2 BH. Got it? And the reason this is the half is if I take a rectangle and I cut it in half, I get a triangle. And then if I have this triangle, no matter where I move the tip of this triangle, it's going to have the same area. All right? So a triangle is pretty much half a rectangle. Any questions? Hopefully not. This stuff's easy. Let's go to the area congruence postulate. If two polygons are blank, then they have the same area. What do these things have to have the same area? Another word for equal, which is good, congruent. We're using the geometric words. What does a congruent symbol look like? Correct, it's an equal sign with a little squiggle above it. Or we equal sign with a little similar figure above it. Area addition postulate. This is a very easy one. The area of a region is blank the area of two non-overlapping parts. So these two parts don't overlap. So what are you doing to these two parts if you find the area of the whole thing? You're putting them together. So when you put things together, it would be the, very good, it would be the sum. Oh, jumping up here, the two areas equal each other. Areas equal, triangles are congruent. So we said before sum. So the total area is area 1 plus area 2, or area A plus area B. Got it? Awesome. All right, so next postulate, subtraction postulate. And this is going to be used for the irregular figures. Area of a region is the blank of the areas of its overlapping parts. So now the parts overlap. So what you do is you have A right here, and B is like a hole. So it's like if you had a piece of wood, so you're in wood shop, and you cut out the middle of the piece of wood, what would the area be of the piece that's left over? So when you cut something out or take it away, in math terms, you would find the blank of the two parts. You would find the, because the D, good, difference, okay? All right, so difference is what symbol? Subtraction. Any questions regarding these? Oh, actually, that's a stupid thing because you can't ask me through a video. You can email me. Find the formula of the areas. Find the area of parallelogram ABCD. First thing, what kind of figure is that? It is indeed a parallelogram. So, what's the area of a parallelogram? Good. It is either base times height or base times width. So, the first method to do this is the base is extended to measure the height. Now, which one of these is the height? Remember, the height makes the right angle. So, this right here, the red and the yellow, are the actual figure. This you just extend out to find the distance between the two. So this just gives you 4, which is the distance between the two bases. So the extended height is CE. So the base is what? 4 is between which two bases? The red bases. So that is 9. All right, AD, which is 9. And the height is CE, which is 4. So using our formula, base times height or base times width, like I said, it doesn't matter which one you use. You're going to use 9 times 4. And 9 times 4 is 36. That's fairly simple, right? Now, because you're given a lot of information here, you can solve this the second way. See, I use these two yellow bases, okay? I'm going to say AB and DC. Now, what would its height be then? So the height, the difference is not 4. 4 is not the distance between these two. Distance between these two is the yellow. It's BD. You see how it makes a right angle here? When it goes up here, since these are parallel, it's going to make a right angle here as well. What's the height? Height is BD. So the base of the yellows is 8, and the height between the yellows is 4.5. Base times height, 8 times 4.5, which is 32 plus 4, 36. And there we go. And look at that. I didn't even have to do the math. It was already done. Which way is the right way to do it? Whichever way you chose and got the right answer. All right, so now what we do is find the perimeter and area of the polygons. So we're going to throw it back in perimeter, because how can you leave geometry class without doing perimeter and area? Very strange that they don't have it in the book. But perimeter is the distance around something, in case you forgot. Okay, so the inside doesn't matter. All that matters is the outside. So right here you have a triangle. What number don't we care about? We don't care about the height right here, the inside. So what we're going to do is when we find the perimeter, we find the distance around the outside of the triangle. Okay, that's a linear distance. So if we were talking about, say this units was feet, it would be feet. When you're dealing with area, it's a square. It's 2 dimensions. Remember we did 1 dimension, 2 dimension, 3 dimensions at the beginning of the year? So that'd be like square feet. So you would do 55 plus 35 plus, where'd 66 come from? It comes from 45 plus 21, and that's your 66. You add them all together, and you get 154. All right? Find the area. Area of a triangle is base times height. So the base here is the whole entire base, 45 plus 21, which we said before is 66. And the height here is, with the right angle to the opposite vertice, is 28, and your answer is 924. All right? Remember, opposite vertice with the triangle. That kind of shape is a parallelogram. Very good. So to find the perimeter, we go the distance around. So 10 plus 17 is not our final answer. We need to know this, which is also 10, and this side, which is also 17. Add them all together. Let me pop over here. You get 10 plus 10 plus 17 plus 17, or to do things easier, 2 times length plus 2 times width. That's how the formula actually looks like for a rectangle. So 2 times 10 plus 2 times 17. 20 plus 34 is 54. Good. Area. What was the area? Base times height, right? Base times height. The base is 17 and the height there is 7. Type them in your calculator, you get 119. Good. 924, 119. Back over here. All right. So find the area of these 4 polygons. Go. All right. That was quick. First one. Square. Side squared. 7 squared is 49. You can also say 7 times 7 is 49. Whatever floats your boat. Rectangle, length times width. Simple. 12 times 26, 312. Triangle. Ooh, you have to establish your base and your height. Base and height has to be a right triangle, and it's pretty much you multiply the 2 things that are not your hypotenuse. Hypotenuse is 5, so we don't multiply that. You do 4 times 3, which is, what's 4 times 3? 12. No, half of 12, which is 6. All right, don't forget the half. Triangle, the base is only 6. You don't count the extended part as part of your base. So it's 6, and what's the distance from here to the opposite vertex? It's not this, it has to form the right angle, so the height here would be 10. All right, half of 6 times 10, half of 60 is 30. Good? Simple. All right, do 10, 11, 12. You're given the areas, and now you have to find x. Ready? So, first thing you have to do here is use your formula. Area is length times width. So 18 equals 2 times x. Your length and your width really don't matter. They're interchangeable because you're multiplying. And 2 times x is the same as x times 2. 2x is 18. So you divide both answers by 2, and x equals 9. Wow, that was tough. 121. Square is s squared. So, because this is s squared, right? Square root of x equals, square root of x squared equals x, square root of 121 equals 11. And that's it. And finally, 1/2 base times height equals 1/2 of x times 12, and that whole thing equals 72. Half of 12 is 6. You don't distribute because it's just multiplication. If there's a plus, then you would have to distribute, but it's not. So you get 6x is 72. Divide both sides by 6, and you get as an answer 12. All right? See? Easy. Why don't you guys try some of regular figures, which are 13 to 15. Now, since they're non-overlapping, what you need to know is you're going to be adding the area. So you pretty much cut these things into pieces that you know how to take the area of, a parallelogram, triangle, rectangle, square, and then you find the area of each one of those parts, and you add it together. So this one I kind of gave you a hint right here. What you should have done first is find the area of the square. I'm sorry, that's not a square, it's a rectangle or parallelogram. So that's length times width. Now this 24 is not this distance. The 24 is the total distance across the top. So you're going to use, and the 6 is only half this, or not half, a little more than half. So you're going to have to use the 18 and the 10. So 18 times 10 is 180. Now to find the area of this, we need length and width, or base and height, and however you want to say it. But we're not given those two. So we need this piece and this piece. So how would we find those pieces? We would go back to the line segment postulates we used to use. Line segment addition, line segment subtraction postulates. So since this whole thing right here is 24, and this whole thing is 18, we can find this. Since this whole thing is 10, and this little piece is 6, we can find this. Now the way you do it is, we want to find, like I said, half times base times height. First off, this piece is 4. How did I get 4? 10 minus 6 is 4. 4 plus 6 is 10. Rectangles, opposite sides are equal. All right, so now to find this, what do you get? Good, you should have said 6. 24, the whole distance minus 18 is 6. So 1/2 of 4 times 6 is 2 times 6, which is 12. Now, these are the areas of each piece. Now, what do we do with these two pieces since they're non-overlapping parts? We do not subtract them, we add them. 180 plus 12 is 192. Right? And that's it. 14, 15, go. Give me a chance. All right, let's start with 14. You could have done this 2 ways. I'm just going to show you one. You're going to make 2 rectangles here. So I cut this the same way. You could have cut it horizontally here too and got the same answer. So let's just see this though. 18 and 16 gives you 288. And then this little rectangle here, well, since this is 8 and this is 18, this is 10. 18 minus 8 is 10. And then 20 minus 16 is 4. All right. So 10 times 4 is 40. Take the 2 numbers, since they're non-overlapping parts, you do your addition postulate, and you get 328 as an answer. Awesome. Last one. Oh, this was a little tricky. This gets some people every year. Cut it that way. Don't make trapezoids. Always try to make rectangles. That's the easiest way. So the first one, length times width, is 15 times 8 is 120. Now here's what gets some people. Now, these little light green marks mean these two sides are congruent. So if this is 15, this bottom piece is also 15. Whoops. And because this is 18, the whole thing, 18 minus 8 is 10. So you got a 10 and you got a 15. Now, this 10 is not the slant length. The 10 is the distance going up and down. So this would be 15 times 10. 150. 120 plus 150 is 270. Not too terrible, right? All right, move to the next one. Find the area of this entire figure. Now, I was nice. I split it up for you. Got an answer? Let's see what you got. So the first thing I'm going to do is I'm going to find out what each piece is. Since this is 10 and this whole thing is 22, 22 minus 10 gives us this piece, which is this piece, which is 12. All right. Now, next thing I can do is this whole thing is 36, and this piece is 13, and this piece is 7. 7 plus 13 is 20. 36 minus 20 is 16 for this piece right here. Now, I got all the things I need to know to solve this problem, I hope. And let's see. So I'm going to find the area of the rectangle first. 16 times 20, length times width is 192. Now, I'm going to find the area of this. 1/2 of base times height. Half of 12 times 13 is 6 times 13 is 78. And I'll find the area of this triangle. 1/2 of base times height. Where are we at there? Down here. And I got this to be 23. This is how. If this thing is 16, 16 plus 7 is 23. So my height is 23 and my base is 10. So it's 1/2 of 10 times 23. 5 times 23 is 115. These are non-overlapping parts. So what do I do to all 3 of these? You add them. And when you add them together, you get 3 to the top. Right. See? I can make these things a little difficult. Let's do some more problems. Find the perimeter and area of the polygon. So you can do both. Ready? Perimeter, distance around. 17, 10, 21. Not the stuff in the middle. 48. 48 units. Area, base times height. Triangle's area is 1/2 base times height. Look for the right angle. The 2 side lengths touching the right angle. So it's 1/2 of 21 times 8, which would be 84. And if we were dealing with units, it would be 84 square units. Right here, find the perimeter. Parallelogram, so opposite sides are parallel. 2 times 20 plus 2 times 30. 2 times 30 plus 2 times 20. 60 plus 40 is 100. Look for the right angle. That base, that height. 30 times 17. No half because it's not a triangle. And your answer should be 510. Square units, regular units. Triangle. Now, how do we find the perimeter if we don't got this side? How do we find the height if we don't got this side? What can we use to find the missing side of the right triangle? Give you a hint. 2 words. Another hint. First word P. Second word T. You said Pythagorean theorem. You are correct. 5 squared plus height squared equals 13 squared. 25 plus b squared is 169. B squared is 144, and b is 12. Or you can use one of your Pythagorean triples to do 5, 12, 13. Now we're ready to rock. To find the perimeter, distance around, 5 plus 12 plus 13 equals 30. To find the height, once again, it's the one that's not the hypotenuse. Base and height are the two sides that are adjacent to the right angle. Half of 5 times 12 is indeed 30. Give yourself a round of applause. Problem number 19. Let me go. There we go. So, could do this problem two ways. What do you want to do? Perimeter. 6, 12, 12, 6. 2 times 12, 2 plus 6 times 6 is 36. All right, area. Base times height. 12 times 4 is 48. 6 times 8 is 48. You choose whichever way you like, and you will get the answer. Right, good. Over here. Pretty, got some good movement today. All right, so now we're going to do a multi-step problem. This problem is throwing a word problem into the real life situation. All right, so you're just not finding the areas of abstract figures. So here you go. A robotic vacuum cleaner can clean 2 square meters of carpet in 8 minutes. How long does it take to clean a carpet covering a room that looks like this? So the M stands for meters. So you got 9 meters, 9 meters, 5 meters, 5 meters. So it's a pretty large room. Bigger than any room I know. But so see if you can do it on your own, and then I'm going to walk you through it. Right? So area equals the area of the blank plus the area of the blank. So you're going to cut this into 2 pieces. My cut may be different than yours, but just wait to the end to see if your answer is right before you erase everything. So I cut it by the top and the bottom. So it's the area of the rectangle up here plus the area of 5, and 5 is an area of a square down below. Okay, if you did it the other way, you would have the area of a rectangle and a rectangle. Okay, so the area equals, so the first one is area of the rectangle on top is, what do we have? 9 times 4. Area of the square down below is 5 times 5. 9 times 4 is 36. 5 times 5 is 25. Add them together to get 61 square meters. Remember, area is square. Now, how long does it take the vacuum to clean? Now, you should know that time is area times rate. So the amount of time is how long? We don't know. What don't we know? What are we looking for? How long it takes. So we're looking for time. So it's going to equal some type of minutes. So what's our area? Is 61. And our rate is how many minutes per meter squared? 2 square meters in 8 minutes. So it's 8 meters per 2 square meters. Now the reason you go minutes over meters squared, remember, is whatever the units are here, since they're in the numerator, the corresponding units have to be in the denominator, remember, because you want these meters words to cancel out. 8 divided by 2 is 4. So it's 4 minutes for 1 meter. 61 times 4 is 244 minutes. So it takes 244 minutes. About how many hours is that? 60 minutes in the hour. You can estimate that to be 4. That's pretty easy, right? See that? You guys could solve these now. All right, we're going to do this one. How many of you guys painted a barn before? Raise your hand. Oh, I knew you guys all paint barns. So, if you buy paint, so you can paint the side of a barn. A lot of barns in Linden, right? A gallon of paint covers 350 square feet. How many gallons should you buy? First thing is find the area of that part of the barn. Well, you got a rectangle here. That's 26 by 18. Area of that piece is 468. What do you got up here? You got yourself a triangle. Now, this triangle is a little strange. You don't know what these are. You know they're equal because it's a isosceles triangle, and you know the hypotenuse is 26. So can we find what the x's are? We can use the 2 words. First word begins with P. Pythagorean theorem. X squared plus x squared is 26 squared. If you have an x squared and you add it to another x squared, how many do you have? 2x squareds, okay? And that equals 678. Follow me still? What do we do? 76. Divide that side by 6. What am I doing there? Oh, they're backwards. This should be under here. So you get x squared equals 338, and you take the square root of that, and you get x equals 18.4. These should be flipped. I don't know what I did there. So anyway, 18.4, 18.4, that's your height and your base and your height, and they can be equal, all right? Half of both those multiplied together, and you get 169. What do I do with these two numbers? Because they're non-overlapping parts, you add them together, you get 655 square feet. 1 paint gallon covers 350. So what do you do with this number in the 350? If you said divide, that's good, because the gallons that you paint you need is the area over the coverage. So 655 divided by 650 equals 1.9 gallons. So you need 1.9 cans of paint, right? Nope. You need 2 gallons. All right. Why do you need 2 gallons? Because each paint can is a gallon, right? You can't buy 0.9 of a gallon. You can't buy 0.9 of a can. You have to buy the whole can. So you have a little extra left over. You could touch up another piece of the barn if you want. Paint yourself a birdhouse or something like that. But you need to buy the 2 gallons. Good? All right. Problem 22. Go. Here we go. Base of a triangle is 4 times its height. We did something like this before. The area of the triangle is 50 square inches. Find the base and the height. So I want you guys to draw this. We did this before when we did proportions and word problems. So the base of the triangle is 4 times its height. So if the height is h, the base is 4 times that. It would be 4 times h, which is 4h. So if we draw a picture, why don't you draw a little picture? Okay? You should have your height, and you should have your base, which is 4h. All right? You can do this a bunch of different ways. You can make it a triangle that looks like this, put the height in the middle. It doesn't matter. All right? Area equals 1/2 base times height. The area is 50. So 50 equals 1/2 your base, which is 4h, and your height, which is h. Good so far? 50 equals 1/2 of 4h times h. Half of 4h is 2h. 2h times h, when you multiply variables that are the same, you add their exponents. 1 plus 1 is 2. So it's 1/2 of 4, which is 2, and then h times h is h squared. Divide both sides by 2. 25 is h squared. What do? You square root h, and you get 5. So the height of the triangle is 5 inches. What's the base? 4 times 5, which is 20 inches. Real quick, what's the area? If you're using a calculator, you're wrong, because it's right there. It's 50. Half of 20 times 5 is indeed 50. Right? Go. Oh, that's it. There we go. So that is the simple areas that we'll be going over. We'll be going over a couple more of these. Just make sure that you guys have any questions. Come find me. Ask me the answers. And I'll help you, even if we're not in school anymore. All right? So have a good day. Till next time.